So I've reviewed the project that we did last year and stepped through it. There were a few questions from students kind of made me want to go back and explore what I had said in the videos last year and then kind of reevaluate things. And I did, and I came to some surprising, I guess, conclusions. One is I hadn't labeled the project very well last year because when I came back to it, it was very difficult for me to figure out what was going on and what we were trying to look at our evaluation sheet. So here is a kind of a reorganization, just slightly reorganization of that sheet. It really shouldn't be much of a hardship if you just finished the last video. But I've added this floor plate, top of steel, and we can see in this the all of the elements in it. But the important thing here is we can see the tributary loads, and then I've added a label to them. I call this A condition and B condition. And I guess stepping back just for a second, the big issue here is the A condition is a unique condition, and if we go to the top of steel, I don't know if it'll show you top of steel with no roof, and we look at this condition here, which is where that section drawing is done. We find that these are unique areas within this system, and I don't know if the mass is showing in this. I don't think it is. But this is where I take these two section cuts, and this is where our tributary load is that we're dealing with. And the unique part here is that we were using these. The way this was structured is these are supported at the last point here. So this is like an outrigger. So it's 2 times the amount of back support of the beam for every third of its extension out, and it didn't need to then continue over here structurally. But that meant that all of these that were being analyzed had a different structural relationship to the grid system. So this idea that these cantilevered elements are no longer going all the way back here, these elements that are sticking out at the very edge of the building, because this is the last column right here, because these aren't coming all the way back here, the loads that are going to be on this structural member is going to be unique. So that calls up that one unique condition that I've identified. And that one may be a little bit difficult for you to see, but nonetheless, this is one that's pretty easy to see, I guess, structurally. The idea here is that in this condition, we have the last supporting column at position E, and then these elements extend out or cantilever out. And you can see the cantilever here. If we were to look at a full, I think it's south elevation, you can see this is the front column load, but behind that would be the next load. You can see how this is a cantilevered beam out over this pin. So that creates another unique structural point of load. Worthy of analysis. Excuse me, I lost my sheet here somewhere. There we go. So that's another place of analysis and another place that we've collected a series of loads and then are expressing it out over tributary loads expressed out over this one beam element. This one we're going to take a specific look at and do a calculation in the next video. So now stepping back, imagine you're going into a meeting and you've spent days looking at all of this structure, and you've identified a few places that you think are of concern or where you think are critical elements to do the calculations for things. Obviously, this idea of the tributary load on the column is critical, and this is square, but the value of this drawing is it shows you that tributary load is 65 feet across. In this case, it's 65 by 65. So you can take those two dimensions by the amount of load per square foot and come up with an idea of the load on this column. And this is a complicated condition. This is a very slender column that's unsupported, and basically because of the nature of them tapering at the end, they're a pinned condition. So I think that's obviously a very critical point of what you would want to have as a discussion with the structural engineer. And I've created a kind of a dialogue note on that. This other condition, condition A, you'll see that I've created 2 views for it so that you can see what structural elements it's are being supported by it. But more important, this time I've added this idea of labeling it a condition to correspond with this diagram, and B condition corresponds with this one. And this is the one we're going to look at in detail, this idea of this cantilever of this element. In many ways, this is a little bit misleading because this looks like we are considering a load that's just a simply supported beam, but the beam element that we're really trying to analyze from this view is this one right here, and that one right here in the transverse section is this one sticking out. So in some ways it probably would have been better if I would have highlighted this beam for analysis and then maybe outlined it here. And what will be really critical when we look at its stresses will be, this is a cantilevered beam, and there'll be very high stresses here, and its failure mode will now be much different than, let's say, a simply supported beam where we're looking at deflections. So we'll pick that up. We'll pick up that idea of analysis. So in the sheet that I'd like to see is some kind of ability to kind of pull all of these elements together into a document. I think if you step back and think about our overall accomplishments here, we've made custom elements for our structural components. We've aligned them carefully to a grid system, and we've begun to do some of the analysis for sizing of what those grid components are. And we've all done it, and we've done it all in a complete model space, which means that it's easy to make changes and then reiteratively look at the redesign of these components after we have an engineering meeting. So in the next clip, we'll pick up on the idea of looking at this cantilevered beam using Web Structural Calculator.